Hello, my name is Alex Josh, and I'm the host of Mindful AI Coding. Today in our lightning lesson, we're going to talk about drift and what happens to software over time. For those of us that have been in the business for a while, you know what this means. But for those that haven't spent a lot of time around big code bases, what happens is that the larger your product gets and the more engagement you have, the more things you change, the more things start to move around. And this is called drift. And it's normal. It's almost like gravity where it pulls you down in a certain direction. So it's not something to really be concerned about, except to the extent that you don't know that things are changing and you're not managing it effectively. And that's what this lesson is really about. It's about managing that change to make sure that it's not going in unexpected ways. So it's okay to change the app if you want to change the app, but do so intentionally. So, for example, let's say that you decide to add a new feature, and that new feature has three or four things that it does, and it needs to talk to the database in a different way. And so you make a very subtle change to the way your data persistence layer works, and then suddenly, like the rest of the app stops working. Right? That kind of thing, by the way, happens all the time, and it happens to professional programmers, but it happens to AI as well. And so what we do is we have drift detection, and we have tools built into our stack that prevents us from breaking other parts of the application. And this is something that most professional software organizations do already, but when you're using AI, it may not be obvious that you need to do this. And in fact, it's even worse with AI because every time you make a check-in, every line of code you write, you have more possibility for drift. AI is much faster than humans, produces more code, therefore, well, more drift. So this is actually a bigger problem for AI-based setups than it is for human-based setups, although it's still the same problem. It just happens much faster. So the first thing that we do is we architect the site in such a way to isolate our changes into small pieces. The front end, back end architecture traditionally, and usually you actually have three tiers at least. You'll have a front end, back end, and then a database. But right now we'll just talk about the front end and back end. What you want to do is you want to make sure that the front end is talking to the back end in a very structured, very controlled way. You want to make sure that you know exactly how they're talking to each other. Now, if you're just starting out and you're building a SaaS application, you probably only have one thing talking to the back end, your web UI. And you're like, well, why should I bother having this formal contract? Why do I need this? Well, what happens if you suddenly want to build a mobile version, or you want to allow somebody else to talk to your backend through an API, or gosh, let's have a command line version of this. So API, there could be other reasons. And so it's just good practice to separate all these parts and pieces out into front end and back end. Then what happens is that every business function has its own little microservice, a backend service. So auth or orders or search or whatever, users, every one of these are small little pieces. From an AI perspective, this actually makes the AI much more effective because now you have a dozen or 2 dozen or 3 dozen really small components. And those components are self-contained. And if you make a change to them, everything else doesn't have to know about that change unless unless the API changes. So it turns out that the boundary of control is now the API, not the code inside that box. You can change the code inside the box all day long, nobody cares. But if the API functionality changes, that's what really matters. And so that's why API contracts are so important. Maintain that external contract. Nobody knows, nobody cares how the back end works. That's the idea. So you're isolating your front end from changes made to your back end. And the contract, that box in the middle, helps ensure that that's actually true. In the industry, this is a solved problem, like a lot of these problems. And I used to work with something called Swagger back in the day. I was actually, friends with the folks that came up with Swagger originally, and that's now something called OpenAPI. So OpenAPI is kind of the default standard way to do this in the industry these days. There's some others, but you don't see them very often. OpenAPI is kind of the way this is done. And so what happens is that you can ask AI to document your API using OpenAPI. You take that documentation, you put it in the code base, you commit it to GitHub just like you did everything else, and then you write a test that say, hey, does the current code conform to this spec? And if yes, great, you're good. If not, oh shoot, we have drift now. And it could be a very minor thing, right? Like we used to have two required things and now we have three, or We change, so it could be something very significant, like it used to be an integer, now it's a string or something, right? It doesn't really matter. The point is the spec it's changed. Now, maybe this is very intentional and you want to change the way the application works. That's fine. No problem. Fix the spec. But now everybody who calls into that app is like, wait a minute, I called into that API and this spec has changed. Oh my gosh, I have a problem now, right? So it's this process that alerts you that something has changed. Also, when you check in the new version of the spec, that itself is a trackable change. So later, if you do this incorrectly and all of a sudden some call is not working anymore, you can ask your AI to say, hey, did we change this spec? Go in and look at recent commits to see if this spec has changed recently. And it can go in and look at the swag in the I keep saying Swagger, the Open API spec that, and oh, you know what? 3 check-ins ago, this API spec changed, and that's why we're not working anymore. So boom, now it's very quick and easy to fix. On the other hand, if you make a mistake and you change the way this subsystem works unintentionally, it's like, shoot, I didn't mean to do that. That's not what I wanted. Hey, revert this change. And so it's a check upon the process. And especially if you're doing coding where you're not really writing code yourself and the AI is writing all the code, if you're not technical at all, this becomes a really, really important check to say, did my AI do something that's going to cause problems later? And how do I even know what AI is doing? Well, the answer is checks, right? This is, trust but verify. You want to watch what it's doing and you want to build these tests to make sure that things don't just randomly change underneath you, because then you could break the entire app and not know what happened, right? And that's the worst case scenario. And so you want to do this at every check-in, right? You want to check that the spec is correct. You want to check that it's called a unit. You want to do a unit test, and you want to check that it still works. So all of this checking is all baked into your commit. And I've talked about this in other units, but you definitely want to do things like security checks and API drift detection. You want to do that as part of your commit process. So every time you attempt to commit code, this happens. And if there's something wrong, you fix it right now. You don't let the AI just skip the test, right? So Claude is very famous for saying, you know what, I don't think I broke this, so I'm gonna just go commit anyway because this is a pre-existing problem. No, 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 no. You broke it, you built it, you fix it. Never allow your AI to bypass these checks, because what will happen is this small problem you have now, 3 commits, 10 commits, 100 commits later, now it's so deep into the code, you have no idea what broke and you'll never fix it. So stay on top of this. Don't let the AI check in without passing these tests. Okay, so that's our lightning lesson. So drift is silent, and the faster you go, the more drift you have, right? So this problem is getting worse and worse and worse, the better and more confident your AI tool becomes. Architecture is your first defense. Make sure you're using a good microservices architecture or something similar. It will save you in these situations. OpenAPI is kind of the industry standard to solve this problem. There's a lot of open source tooling to do things like to write OpenAPI contracts and to test them and things like that. So I would strongly suggest you use OpenAPI and tell your AI to use OpenAPI to solve this problem. And then make sure this is part of your regular process that you always validate it. All right, well, thank you so much for listening today. This is part of a much larger Maven course called Mindful AI Coding. And I would love to have you join us in a session. So there's cohorts up and running right now. If you go to Maven and look at my profile, Maven Ajosh, you can see open cohorts. Hope to see you soon. Thank you so much.